Hello and welcome
to the ninth module of the unit devoted to Brousseau and the theory of didactical situations in mathematics in the project ICMI Awardees Multimedia Online Resources. We will be looking in Module 9 for a new development of the fundamental situation concerning numbers in order to include the ordinal meaning of natural numbers. Since we are looking for a fundamental situation for ordinals, we need a milieu in which it is possible to consider an order. So we're looking for categories of the physical world that are ordered or can be ordered. Time is totally ordered, so events, gestures, speech are ordered. However, in this module, we won't consider time as a possible source of a milieu because it might be particularly complex to implement. However, space is another possibility. But three-dimensional and bidimensional spaces cannot be totally ordered. On the contrary, a one-dimensional space, that is, a line, can be totally ordered. To create this total order, we need an origin and a direction. We will first look for a suitable milieu in the context of one-dimensional space, a line including an origin and a direction. But first, we will return to the milieu of collections we have used to introduce the cardinal number. In Module 8, the milieu consisted of two collections. Here, two collections of beads. From the cardinal point of view, the red and blue collection on the left has 10 beads, and the yellow and blue collection on the right has 11 beads. The beads in the bags are not ordered. To count them, you can take away any beads out of any bag. We will now order the beads. To do this, take two knotted lines. The knot of each line will be the origin of the line. The direction goes from the knot to the other part of the line. If we string the beads from each bag onto the knotted lines, we have now ordered the objects on the knotted lines. We'll now consider the relation to have the same position applied to the two blue beads on each knotted line. Starting from the knots on the line, we come upon the first beads, then the next ones, and so on until you reach the blue beads. This is a term-to-term correspondence of the ordered beads on the line. It shows that the blue beads are in the same position on both lines. We could also say that starting from the knots, we come upon the first bead, then the second, the third, the fourth, the fifth. The blue beads are the sixth beads on both lines. We could also say that starting from the knots, we come upon the beads number 1, then number 2, number 3, number 4, number 5. The blue beads are number 6 on both lines. In English and in most languages, there are two sequences of number words. The sequence of ordinals, which are used specifically to describe positions in time or on a line, and the sequence of ordinary numbers words, which are used both to name cardinals and for other purposes. The total number of beads, that is the cardinal aspect, on each line is not the same, since we have 10 beads on the red and blue line on the left and 11 beads on the yellow and blue line on the right. But the blue bead is in the same position on each line, which is the ordinal aspect. The number of red and yellow beads between the knot and the blue bead is the same, 5 on each line. So there is a relationship between this cardinal and the position of the blue bead. Now lay out the two lines, placing the knots one under the other and arranging the lines in the same direction. We can repeat the term-to-term corresponding, starting with the knots as before. We can now make an important observation. The spacing of the beads is different on the yellow and red lines, but this doesn't change the conclusion. The blue beads are in the same position on the lines of beads. This is what we call the discrete position. We will now illustrate an aspect of discrete position. On this line, we have some objects. To define a position, we need an origin. This origin can be denoted by the number 0. An important point is that the number 0 is not necessary in the context of cardinality, whereas it is an essential element in defining a position, the origin. On the slide, the origin is on an extremity of the line, in which case the direction is implicitly defined from bottom to top. So we can deduce the numbers that denote the objects on the line. 0 for the origin, 1 for the smiley, 2 for the heart, and 3 for the star. The star is in the third position in this coordinate system. Now let's select the other end of the line as the origin. This origin is still denoted by the number 0, but the objects on the lines are denoted by different numbers than before. The numbers that denote the position of an object depend on the coordinate system. We can now make a few remarks about the discrete position. The correspondence between number and discrete position is only established if there is an origin and a direction. So it is not the objects themselves that are associated with a number, but the position of those elements in an ordered list. A very important comment is that there is no measurement unit associated with discrete position. This can be illustrated by the position of a person in a queue. Being fifth in the queue does not mean being at the same distance from the fourth person in the queue as from a sixth person in the queue. Discrete position refers only to order and does not imply measurement. In a fundamental situation of natural numbers as ordinals, we can list the components that we have identified. In the milieu, there are two different finite discrete sequences which are totally ordered and which we can call lists. The definition in ACT is therefore two elements, each belonging to two lists, have the same position in their respective lists if it's possible to match these two distinguished elements by an ordered term-to-term correspondence. This correspondence starts by matching the two origins of each list, then continues with the two successive elements and is repeated until the distinguished elements are reached together, in which case they have the same position in the list, or until one distinguished element is reached and not the other, in which case they do not have the same positions on the list. The stake can be formulated as follows. Given a model list and a distinguished element in that list, determine whether a distinguished element in another list is in the same discrete position as the one in the model list. The process of institutionalization transforms situational knowledge into the intended institutional knowledge. A possible process of institutionalization is as follows. It starts with the recognition of a useful piece of knowledge. The position on a list is considered as a useful piece of knowledge in situations. An oral sequence of odd number words is a useful situational knowledge to denote a position. The position of elements in a list can be associated with a sequence of number words. Since this sequence of number words is ordered, each number word can be used to denote the position of each element in the list. The list of number words can be a special list. 0 for the origin, first, second, third, etc. on the usual list of numbers. 0 for the origin, then 1, 2, 3, etc. for the successive elements. This is the ordinal meaning of numbers. We now present a first synthesis of a fundamental situation of discrete position and ordinals. Since discrete sets are not ordered, we need to introduce order as variable of the fundamental situation and the object that we have called list or sequences. The noted lines and bead situations created by Margolinas and Wozniak are a possible instantiation of this milieu and of the transposition process. The relation between lists to have the same discrete position is an equivalence relation, and the equivalent classes of the relation are the ordinal numbers related to discrete position. Another meaning of natural numbers is thus obtained by this fundamental situation. We are now going to extend the concept of ordinal numbers. We can consider the case of an origin that is not at what end of the line. This time, we need to define an explicit direction. Once this direction is defined, we denote the heart by 1 and the star by 2. What about the smiley? By symmetry, we can decide that the smiley is defined by -1, which reinforces the need to define the origin as 0. Once this decision has been made, if we change the direction, we denote the smiley by 1, the heart by -1, and the star by -2. The instantiation of this situation remains to be designed. If the origin is not at what end of a half line, then negative integers are a useful piece of knowledge in the milieu of this fundamental situation. Here we continue the schema of a fundamental situation of numbers by giving a possible path toward the relative integers as position. To do this, we play with the values of the variable position of origin. To summarize, we can consider that on the whole fundamental situation, two sets are compared by a bijection. In the case of the cardinal meaning of a positive integer, these are discrete finite sets, which we have called collections. In the case of the ordinal meaning of the integer, these are discrete finite sequences with total order, which we have called list. However, integers are not the only numbers, and in the next module we will continue our investigation.
Thank you.
You can now proceed to Module 10 of the unit devoted to Guy Brousseau.